So I'm Jennifer Lay. I'm a PhD student at Scripps Institution of Oceanography. So thanks for giving me the opportunity to talk a little bit about what I've been working on, which is how to use ecosystem services in the context of biofilters. So on to slide 2. So the concepts of green infrastructure, low impact development, and ecosystem services really tie in well together because they're all about how we can use nature and its processes to our benefit. And when I say our, I mean society as a whole for the most part, and whether that's to mitigate climate change impacts, increase air quality, or increase water quality, they all really apply. So what are biofilters really designed to do? Increase water quality, decrease flooding. So slide 3. So most biofilters are designed with some sort of plant community, some sort of filter media, and a drainage system. And then next slide, when it rains, it captures stormwater runoff, which means less water on the streets and hopefully less contaminants in the outflow due to physical processes and bioretention. Next slide, which is slide 5. So these targeted services in part are dependent on the biological communities that are found in each biofilter, which Lisa touched on. Plants have been shown to remove nutrients and heavy metals and hydrocarbons, and the resulting increase in water quality is what we call an ecosystem service. So what exactly is an ecosystem service, since I haven't really defined it yet? So slide 6. So ecosystems have structure, which is the physical, chemical, and biological characteristic that is in the system. And this structure supports function, which is on the next slide, which is just the processes that occur in each system. And then the benefits that we derive from these functions on the next slide are what we call services. So it might be a little bit weird to think about man-made biofilters as an ecosystem, but if we think about what an ecosystem is very, very generally just abiotic and biotic factors interacting, it's a biofilter would pretty much fall under that umbrella. Just as an example of this little flow of structure to function to service, go to slide 9, which shows, biofilter, for example, a biofilter will have plants, a structured plant community, and that will function as habitat for different organisms that we derive some sort of value from. Either we study them as a research project, or we think they're cool, or we just like to know that they exist somewhere out there in the world. So what kind of structures would be important for or in the context of a biofilter? So things like, next slide, slide 10, things like design specs, water flow, connection to other biofilters, and distance to nearest water body. So one biofilter might not do much, but if it's connected to a larger network and it's placed strategically near larger bodies of water, it might have a larger impact. And these structural components of the biofilter are going to affect what kind of function these biofilters are going to provide. So next slide, slide 11. So the rates of water infiltration, contaminant removal, habitat provision, carbon sequestration, green space. So these all provide benefits to us. So slide 12. That include increased water supply, flood control, better water quality, climate mitigation, aesthetics, perhaps most importantly to all of us here, scientific research, among other things. So just as a little, an example of an actual biofilter. So last December, we went up to Los Angeles to go check out some biofilters, and there are some services that you can identify just by taking a look at them. So I'm on slide 13 now. So Elmer Avenue, which is a green street, is a residential neighborhood that has biofilters all along the street. And while we were there, we ran into some residents who were taking a walk and who really seemed to appreciate the green space that these biofilters provided. Another example was at Bicknell Avenue, which is another green street. There were flowering trees in the biofilters, which had lots and lots of bees, which might be, so this location might be important to the local population of bees. And something really interesting that we came across was at the Westminster Dog Park, which kind of lies all along a hill, and there were transient residents that kind of lined up at the bottom of that hill. And if Southern California ever got too much rain, which is usually not a problem here, flooding is a really big issue because we don't really have the infrastructure to handle all of that water. So something like a biofilter that increases infiltration might provide some sort or help ameliorate that impact. So why would we want to use this kind of approach to look at biofilters? And next slide 14, would be because as we use ecosystem services, we can start to put a value on these things and use cost-benefit analyses. So we use cost-benefit as a government, as individuals. Do I want to eat a sandwich for lunch? Do I want to eat a salad for lunch? Which one costs more? Which one tastes better? Do I want to invest in biofilters or a different wastewater management plan? And a lot of times, if things don't have a value assigned to them, it means that they're treated as if they have no value, which might not be the most efficient route. But with ecosystem services, we can start to incorporate a lot of these co-benefits into planning and decision making. So next slide. So there are a lot of different economic valuation techniques that we can use to put a value on these different services. I don't think there have been too many studies on biofilters specifically, but the closest analog, in my opinion, would probably be constructed wetlands, which there are studies for. So just to go over a couple of these techniques really quickly. Slide 16. So the replacement cost method. So how much would it cost to replace a service with the next best option? So if I wanted to put a value on contaminant removal, if I were to get rid of all the biofilters, what is the cost of obtaining the same level of water quality that I just lost by using the next best option, say a wastewater treatment plant? So in essence, we're just asking what the cheapest way we could replace this function or service is. Next slide. So contingent valuation is just a survey method that asks people how much they would be willing to pay for X good or service. So a lot of people will use this method for biodiversity studies, or it's also been used for water quality. So if I would ask people, how much more would you be willing to pay on your monthly water bill to have swimmable water versus boatable water? Next slide. So hedonic pricing, the price of a good or service is influenced by a collection of non-market goods or traits. So this is mostly used in the context of the housing market. So if I have two houses that are identical, completely the same, except for one has a biofilter that provides green space outside of it, while the other one is only cement. The difference in price between those two houses would be the aesthetic value of that biofilter. And then we have, next slide, is benefit transfer, which is just a method of transferring a value you get from one primary study to a similar system. So as I said before, constructed wetlands are, in my opinion, the closest analog to what a biofilter might be doing. And this is a good way to provide a preliminary estimate in the lack of a primary study, which is often expensive and takes a lot of time. So, in addition to putting a value on a lot of these services, what other kind of applications does this kind of perspective give you? an example that I have is urban planning. So the beaches in San Diego bring tons of tourists every year, but when it rains, the stormwater collects contaminants, it washes up on shore, and then it can get people sick, which the government wants to avoid, the local businesses want to avoid, because it keeps the tourists from coming to their shops. So say, for example, what people like one beach better than the other, so they like going to the south part of the beach more than the north part of the beach in this example on slide 20. Um, and we have a limited budget of what we can actually do. So we have to choose where the biofilters might be most beneficial, and that might be where there's a higher density of people. So if we go on to the next slide, this is in a little bit more economic terms, but we can start to map where demand for ecosystem services might be high. So in terms of biofilters, that might be where there's high population density, high vehicular traffic, or places prone to flooding. And the nice thing about biofilters is that they're man-made, so we can choose where to supply them, which doesn't usually happen. So that's something that's really nice. So in summary, biofilters provide a lot of different services just in addition to the targeted ones, and those need to be considered while we're addressing stormwater runoff issues. A wastewater treatment plant might be expensive in terms of infrastructure, energy, and operational costs, but it has a large capacity for contaminant removal, and it employs a lot of people. Biofilters don't require a lot of energy, but they require design, construction, and maintenance. And an ecosystem services perspective allows us to translate all of these factors into a common denominator and compare these things more easily, and perhaps make decisions that will make us a little bit better off. So I'm on the last slide. So thank you. I want to say thanks to USCC grant, because they were our funding source, the organizers of this symposium, and all of you for listening. Thanks.
Okay, excellent. Thank you very much, Jennifer. That's a great talk. So do we have questions?
Yeah, I have a question. This is Stanley Grant. So in one of our earlier symposiums, we had Scott Taylor talking about sort of his industry perspective on biofilters and their application for water quality and water supply. And I think he made two interesting points that would be nice to hear you react to. One is that if you look at green infrastructure as a solution to beach water quality issues, for example, and you raised the application example that involved beach water quality, that basically the price tag associated with that, just constructing these systems, could be more than $10 billion with a B dollars over the next 10 or so years. And so his point was, who's going to pay for that, and would there be willingness to pay? And the other point he raised, or was raised in discussion anyway, is an equity issue. That is that a lot of the pollutant generation and where these biofilters really should be placed within the storm sewer system, drainage system, are located kind of in inland communities, which are often maybe populated by poor people who may not have as much ability to pay, financial ability, but the beneficiaries are actually the rich folks at the beach. And so there's kind of an equity issue that the benefits are all concentrated in a region where a lot of the people who have to make these changes don't see those benefits. So I'm just kind of asking, in the very nice overview that you gave, how you would imagine addressing those two really important questions or issues that Scott raised.
So in terms of your first question, I mean, I don't think that just installing a bunch of biofilters is going to completely erase our kind of our runoff issues on the beach, but it might help. And if we look at kind of more than just like what it might be doing for the beach, so biofilters will provide a habitat for different animals or worms and other small fauna that people might not care about too much, but I mean they're still providing that. They're still sequestering carbon and, or potentially sequestering carbon and stuff. So if we kind of look at them as a whole and look at the whole host of services that they might be providing, it might look a little bit more how do you say it? They might look a little bit better in terms of other options that we might have. And I'm not saying that we should only do this or we should only do this, but finding some sort of middle ground in terms of as we try to kind of mitigate this problem, like how many biofilters do we really need and where can we put them to be the most beneficial, and then where can we do other things as well. In terms of the equity issue, that's something I think about a lot, just living in La Jolla or close to La Jolla and working in La Jolla, because a lot of the people here have the resources to kind of, you can kind of look at biofilters as a luxury good in that like they look really nice and they take some maintenance and some upkeep. So it is a little bit of a kind of a gray situation that I don't think I have the expertise to really touch on very well, but yeah, it's definitely something that I like to keep in mind when I'm talking about a lot of these ecosystem services, because you know when you throw money into the problem, it gets very sticky.
So I wanted to follow up on the question about money, because quantifying the ecosystem services is one thing, and then monetizing them is another issue. You could monetize them, but you don't have to. And I just wonder if you might have a comment about that, and in particular, just in light of the fact that I have colleagues who are vehemently opposed to monetizing ecosystem services for a whole wide range of things. We could talk about why, but I'm just wondering if you could give your perspective on that issue.
I think it's kind of a necessary evil. Money is a very tangible thing. It's something that everybody kind of understands, which makes it a little bit easier to translate and to communicate with other people why these things are important. Like if I say that something has, or something is, you know, preventing like X amount of carbon from getting emitted into the atmosphere, most people aren't going to really like jump at that. But if I say that something is keeping us from spending billions of like $100 million a year on climate mitigation or something, they might be a little bit more that's a little bit more tangible for most people.
I think the concern is that the monetary value might not be that high. And so if you monetize them, so it might be $10 worth of carbon.
Yeah.
If it's hundreds of millions, I think, you know, there's no problem. It's good to monetize it. But I think the concern is that there might be other, you know, definitely non-monetary benefits to society, people, but difficult to quantify. But still, if the values are not high enough, then by going down that route, you might undercut sort of what you're trying to support.
Can I jump in here? I think that right now biofilters are only considered for the value of the water purification functions or water harvest and retention or functions. And I think an important point is that if they do have additional values, that people might be more willing to embrace them. And they can add additional values to environments, like this question about ornamentals and can they be valuable green space. If people see them as having aesthetic benefits or environmental benefits in some way, they may be more interested in having them. So it might increase acceptability.
Well, I totally agree with that. Absolutely. But I'm just wondering if you need to put a dollar value to quantify those benefits. So if you tell people that they have these benefits, either aesthetics or, you know, pollination or whatever, that might increase their acceptability. If you tell them they're going to provide 10 cents worth of pollination, and they're going to provide $4 worth of carbon sequestration, I worry that actually is going to mean that people are going to think that they're not valuable, sort of the opposite. And I'm taking a bit of a devil's advocate position here,
Yeah,
right?
so,
But I just think that is the concern.
But those would be in addition to whatever they're already providing that
Right.
we've already put a value on, right? So those are just, these are additional things that they're providing, not the only things that they're providing, which I think is important in terms of like the biofilter question. And
I guess one thing that I'm confused by, and it may just be my confusion and nobody else's, is how, so getting back to Scott's question of how do you get people to pay for $10 billion worth of infrastructure? Okay, if you start there, is the theory that somehow by monetizing the value, the hidden values of the biofilters, that you will convince people to pay that $10 billion? And I'm just deeply skeptical of that anyway. And it kind of follows on what Rich is saying. You know, for one thing, you have the concern that you know, maybe the ecosystem services on a cost-benefit basis for the set of services you've specifically identified actually don't stack up to the price tag, that there's other reasons to do it. And then the second thing is just, in reality, I don't know that I would be that swayed, you know, by knowing what the additional value was. I mean, I think the marketplace kind of determines that, as you indicated. It's like a luxury item. Your house is beautiful, and so it has more value. And so that's really what drives people to make those kinds of investments.
What about an offset framework? Something where by doing it this way with these kinds of extra benefits that somewhat reduce the total overall cost, it is better than the cost of doing this other way, which is more expensive.
I think the tourist industry on our beaches is worth $10 billion. I think that when you do the numbers, they close our beaches every time it rains.
Right. Well, you know, so one example would be if there was a fee, and I've heard this, maybe it was in Australia, a fee charged for runoff from your property.
Right.
So you get charged $100 for every gallon of water that flows into the stream. And then suddenly it is tremendously useful and interesting to you to retain that water on site.
Well, to your first question in that series of questions, I don't think the government would be willing to invest in $10 billion in any one thing anyways. But kind of having these additional benefits might create like 100 more biofilters that might be very important in that network of biofilters, right? So if we have maybe 10 of them, they might not be doing too much, but if, you know, these additional benefits means that there's maybe 100 of them, then that might be enough to create a bigger impact.